Okay, so now we want to graph a secant function. And when I'm trying to do this, a lot of times, there's a lot to remember in trigonometry, and we don't always remember everything. So I always go back to things that I know. Okay, so what do I know about secant? I know that the secant of t is equal to 1 over the cosine of t. So maybe that will help me. Okay, so just note that. So we're going to be doing a secant of x. And then what's x going to be? Well, let's start with our quadrantal angle, 0. Think about being here on the circle, on the unit circle, okay? And that's going to be, x comma y. The point, I should put the point in, darn it. Okay, 1, 0. Think of that. And so on the unit circle, x is going to be the cosine there, so the cosine is 1, but think reciprocal for the secant, so 1 over 1 is 1. Okay, great. Then let's go to pi over 6. Okay, now I have to think, well, what was the cosine of pi over 6? It was like the square root of 3 over 2. So now I want to think the reciprocal, which is going to be 2 times the square root of 3 over 3. I'm going to have to get a decimal approximation for that, so let's do it right now. Here. I don't remember the decimal approximation for this. That's why we have a calculator. Okay, so it looks like it's 1.2. And the decimal approximation of 1 is going to be 1. All right, now let's think about pi over 4. So, think about, well, what was the cosine of that? And then what's the reciprocal of it? It's going to be the square root of 2. Or you might just remember, or you might look up on a chart or a unit circle. Anyway, so the square root of 2 is about 1.4. And then we're going to have pi over 3. So the cosine of pi over 3 is 1/2, so the reciprocal is going to be 2. So 2. And then let's go ahead and go pi over 2. Now we're here on our unit circle, and so that point is 0, 1. And so the cosine is 0. So when you go to reciprocal it, you're going to have 1 over 0, and that's going to be undefined. Undefined means it's an asymptote. Okay? All right. Let's see. We can keep going. We'll go another, another round here. Let's go 2 pi over 3. And that's going to be negative 2, right? Because you're in the second quadrant now. You're like over here. Okay, so the x is negative. Then we're going to have 3 pi over 4. And so, again, the cosine is going to be negative in this quadrant, so it's going to be negative square root 2, which is going to be negative 1.4. Negative 2 there. And then we've got 5 pi over 6. And that's going to give us negative 1.2. So negative 2 times the square root of 3 over 3. Okay, and then you're to pi. All right, so here we are at pi. And the coordinates for that point are negative 1, 0. So it looks like I'm going to get a negative 1 out of that for the secant. Okay. Now, let's think about the other quadrantal angles. So over here, I've got 3 pi over 2. And that's going to have the point 0, negative 1. I don't always, but sometimes it's helpful to draw out the quadrantal angles. Okay, so that's going to be undefined, which gives me another asymptote. Oops. And then we would be back to 2 pi. And 2 pi is the same as 0, so we're going to have a secant of 1. And the decimal approximation is 1. All right, so let's look at what we have here then. So let's mark off 2 pi. And we'll cut that in half, pi. Cut that in half, that's pi over 2, and 3 pi over 2. Now the other ones, where are they? Well, you know, pi, let's see, we have pi over 2, right? Okay, so halfway between, that would be pi over 4, and then a little bit before that's going to be pi over 6, and a little after it is going to be pi over 3. Okay. Now we're going up to 1, and let's go down to -1. We do have a 2 in there, so oops, I wrote 2. Let's go up to 2, and we can go down to -2. Okay, let's see what happens for this graph then. So when I'm graphing these points, I'm just graphing, points. So x is 0, and I start out at 1. That seems normal, right? Like our cosine curve, But then what happens? Well, I'm going to pi over 6, and it's going up a little bit more. So it's 1.2. Then I'm going to pi over 4, and it's going up a little bit more. Oops. Doesn't want to make a point. Okay, there it is. And now when I get to pi over 3, it's all the way up to 2. Okay. All right. Then what happens at pi over 2? That's an asymptote. So I'm going to put an asymptote in right there. Okay. If I want to put the other asymptote in, I can do that as well. Okay. Let's see. Okay. So I get this curve right here. Oops. Going like that. It's going to run toward the asymptote. So it's fairly skinny. It goes up fairly quickly. Okay, now let's look at what happens between pi over 2 and 3 pi over 2, the two asymptotes. Okay, so let's mark it off here. You've got well, we've got to pi. So let's look at this as well. You've got to mark those in a half for pi over, or 3 pi over 4, and then a little bit before for the 2 pi over 3, and a little bit after for the 5 pi over 6. But all of these values are going negative. So that first one is down at -2. And then you've got a -1.4. So I'll say about there. And then you've got -1.2. And then finally at pi, I'm at -1. Okay? Now, if I don't have the third quadrant on here, but let's say I did. Let's just do a little mini table of values here. So pi, we were at -1. And then it's going to be 7 pi over 6. And that's going to be -1.2. And then you're going to have 5 pi over 4. That's supposed to be a 6. And 5 over 4, that's going to be -1.4. Now, why are these negative? Because you're in the third quadrant. So x is going to be negative. That means secant's going to be negative. All right. And then the last one's going to be 4 pi over 3. And this is all in the third quadrant. And so that's going to be your -2. Okay? All right, so you can kind of think about matching those up, or you could use your unit circle to figure those out. All right, so what does that look like? Well, it means I've got, here's the 5 pi over 4, and a little bit before for 7 pi over 6, and a little bit after for 4 pi over 3. Now, my graph is pretty little here, so it's kind of hard to tell. But you're going to have -1.2, -1.4, and then -2. So it's going to mirror what we had on the other side in the first quadrant. or second quadrant. All right. So it looks like that. And what happens in the fourth quadrant? Well, actually, you're going to get, if you want to fill out the table of values, you can, but it's going to go at 2 pi. You're going to be back to 0, right? And so it's going to go like 1.2 here, and then it's going to go 1.4, and then it's going to go up to 2 there. And so it's going to look like this. Now, sometimes they will draw it that way, just like what I have here. That is one period. It's going from 0 to 2 pi. But sometimes they'll extend it so that it makes like a complete U shape. And so the next time that's going to occur is going to be at, well, it'd be 2 pi plus pi over 2. So what's that, 5 pi over 2? Just trying to switch colors here. So your next asymptote would be at 5 pi over 2, 2.5 pi, that way. And then you can go the other way as well. It'd be over here at negative pi over 2, and you'd have the other asymptote. And draw it. Now, usually when we graph these, we just kind of get where the, I guess, well, I can't call it a maximum or minimum, kind of the bottom of the U, you know? You get that point, and then you just draw, and where the asymptotes are, and then you just kind of draw in the U shape. And then the same thing for the other part down here for the negative values. You just get the 1 point, and then you just kind of draw it in, okay? So that is the secant function. So if you have a stretch factor, it's going to look like y equals a secant, I'll just put bx. So the stretch factor is a, absolute value of a. That's going to be your stretch. Or it could be a compression. The period's going to be equal to, a normal period for secant would be 2 pi. So it's going to be 2 pi over the absolute value of b, okay? Just like we had for the cosine curve. Now, the domain is kind of interesting here. So the domain is going to be, well, it's all real numbers except where the asymptotes are. And so that's pi over 2. And then we're going to multiply that by b, in case the period changes, plus k, where k is an odd integer. Okay, so why is that? Well, you have to keep adding a full cycle to it, you know, a pi to it, okay? And it should say k pi, but it doesn't, so I'm not sure on that. Ooh, I'm running out of time. Okay, so the range, well, you've got the range from negative infinity to 1, negative 1, unioned with 1 to infinity. The asymptotes, those we've already stated. Secant is an odd, it's an even function. Even function. So it's symmetric about the y-axis. Now that helps you. If you know if it's an even function, you can kind of think, all right, picture this as folding, and I know the points are going to line up from the left on the right. Okay? So I'll have to finish this one. The asymptotes come back to this. My mistake is right here. It should have been k, just times k. And then that'll give it to you.